Guys, Mr. Bowman here. Today's learning objective is in green, and we are learning to use inverse normal distribution to simultaneously find the mean and standard deviation. So key part, simultaneously, mean and standard deviation. So for these types of questions, we haven't been given the mean or the standard deviation. We're trying to find both of them. And that word simultaneous comes up because we're trying to use in algebra school simultaneous equations to find out both of those two unknowns, the mean and the standard deviation. The best way to get into this is a question, and I've already got a similar question in blue. Let's just jump in. We'll see how we go. So from Mr. Bowman's Year 11 extension class, he knows the top 10% of students got 85% or more. This must have been in some kind of test. He also knows that the bottom 15% failed, i.e. they got less than 15%. Calculate the mean and the standard deviation of these test results. So key thing to note, we haven't been given a mean, we haven't been given a standard deviation. So our starting point, it's really similar to the regular questions where you're finding the mean or the standard deviation by themselves. But we're going to be doing two things for each step. So the first one is draw normal distribution graphs. This time around, we're going to be drawing two graphs. So we're just going to call it A and B, graph A and graph B. And when we talk about A and B, the top 10%, that's going to be referring to A, and the bottom 15%, all of that stuff will be referring to B. So here's our graph. We don't know the mean and we don't know the standard deviation, but we know the top 10%, so that there is 0.1, got 85% or more, so that there would be 85. And our second graph relates to the second scenario of the bottom people. There we go. So again, we don't know the mean, we don't know the standard deviation, but we know the bottom 15% got 50% or less. So we can see the two graphs set up. Step number 2, just like our other one, we're then going to have to draw our standard graphs. Draw standard normal distribution graphs. So we're going to jump in, we're going to do that. So scenario A, there's our graph. Just a reminder, in a standard context, the mean, don't forget, the mean becomes 0 and the standard deviation becomes 1. So we've got 0 and a standard deviation of 1. And we lose our z value, so we don't know this, but that becomes z. And we know the probability is still 0.1. And we've got to replicate this for scenario B. Oh, that's a poorly drawn graph, but we know this standard deviation is 1. The mean down the bottom is 0. And we know that was the bottom 15%. Oh gosh, I forgot to write that in the one before. Bottom 15%, we lose the 50, and that becomes our z value. So that's A and B for that. Step number 3, we've got to calculate the z values. So calculate z values. For scenario A, don't forget we are using our inverse normal distribution mode, so we'll get that on our graphics calculator here. We're going into stats mode, which is 2, distributions, normal, inverse normal. We need to know a few things. We need to know about the tail. We need to know about the area. We need to know about the standard deviation. We need to know about the mean for each of these. So the tail is a right tail. I'll just write R for right. Area 0.1, standard deviation of 1, mean of 0. Put that into your graphics calculator, you're going to get a z value. So entering that in, go up to the top, our tail is right, so that is F2. Our area 0.1, standard deviation of 1, mean of 0 in from a previous question. We're going to go execute, and that there is 1.2816, and that there had a 4 dp rounding, and I'm happy with that number because I'm expecting this to be positive because it's above 0. If that was negative, I would have been a bit worried I did something wrong. Part number B for this, tail, if you have a look above, that's a left tail. The area relates to the probability, and we had 0.15. Standard deviation, oh gosh, that's the mean. Standard deviation of 1 and mean of 0. From that, we can find our z value, enter that into our calculator. Just a reminder, exit is kind of like your back button. We've got a left tail, area of 0.15, standard deviation of 1 and mean of 0. Execute. Z is equal to negative 1.0364, and that there had a 4dp rounding, and that z value is below the 0, so I am expecting that to be negative, so I'm all good with that. So step number 4, we're now going to substitute into the Z formula. Oh, Z formula. There we go. Okay, so for part A, we'll maybe move over here to save some room. Z is equal to X minus mean divided by standard deviation. So Z is over here. So it's 1.28, 1.2816. That's going to be equal to Z of 85 from the top, minus the mean divided by the standard deviation. We're then just going to do a bit of rearranging here. We're going to move the standard deviation to the other side, which becomes multiplication. So 1.2816 times the standard deviation is equal to 85 minus the mean. And I'm now going to move that mean to the other side. It's going to become 1.2816 mean plus equals 85. So that there relates to A. We're now going to replicate the same for B, and we're going to stop here because our graphics calculator will do the rest for us. So B, same thing. Let's set up our equations. Z is equal to X minus the mean divided by the standard deviation. The Z is up here, negative 1.0364. That's going to be equal to X, which was up the top here, 50, minus the mean divided by the standard deviation. Same thing, this division, we're going to move over as multiplication. So negative 1.0364 standard deviations is equal to 50 minus the mean. And again, that mean minus a mean, we're going to now go plus it on the other side. So minus 1.0364 standard deviation plus the mean is equal to 50. And there's our second equation. So I'm just going to underline the two equations. In our final step, I've gotten rid of some of our question to help us out with that. You're now going to solve, but this time around, instead of solving for one of them, we're solving for both the mean and the standard deviation. So just a reminder about our two equations. They come from down the bottom. We've got 1.2816. Standard deviation plus the mean is equal to 85. So that was the finishing of A. And the second equation, negative 1.0364, standard deviation plus the mean is equal to 50. We've got two simultaneous equations, and we're going to use our graphics calculator to find out the answer to this. You can use algebra to solve it if you're confident enough, but let's go to menu. You're now going to go to the equation mode, which is A. You're now going to go to simultaneous solver, and a number of unknowns. We've got two, being the standard deviation and the mean. This time around, you can see it says X, Y, and C. C relates to the number by itself. That's sorted. And we're just got to figure out, well, these here can be the Y values, these here can be the X values. So we're going to start off at the top. We're going to enter in the number in front of the standard deviation. So it's 1.2 816. That relates to the X value. And then we're going to have one standard deviation, or one mean, and that's equal to 85. So hopefully you can see how the equation pops up there. We've got 1.2816, one of those, 85 over there. Now we're going to do the same for the bottom equation, negative 1.0364. Oh gosh, I must have deleted it by accident. Negative 1.0364. There we go. And we've got 1, and we've got 50. And we've got our two equations set up. And now we're going to go equals or execute, and that'll tell you the two values, x being, don't forget the standard deviation, y being the mean. So our standard deviation is going to be equal to 15.1, and don't forget R is related to the test score or percentages, and that had a rounding of 1 dp. And our mean going down to y, so our mean was equal to 65.6%, also a 1 dp rounding. So guys, hopefully you can see how the 5 steps of this type of equation was really similar to the 5 steps of the other equations. Really, really tricky question. This is definitely a big excellence question, but we learned how to find out the mean and the standard deviation using simultaneous equations. Thanks so much for watching, guys. Now let's get into heaps of practice.